Okay, before I show you how to calculate the displacement of the previous question that we have been working on, I want to show you just a quick example with a constant speed that hopefully will explain why the displacement is, or the distance traveled is, or can be found by getting the area between the line graph and the time axis. Okay, so what I'm telling you is the distance traveled is can be found from a velocity time graph or a speed time graph. Getting the area under the curve is what we say, but more specifically, I should say, the area between the line graph and the time axis. So we know that speed is equal to distance over time. And we also know that distance, if you multiply time on both sides, will be speed multiplied by time, just from that silly triangle. Okay? So if I wanted to work out the total distance here, I hopefully would spot that it should be the speed multiplied by the time. Okay? So if I look at this graph now, I can see that, well, my speed is 8 meters per second. So that's 8 meters per second times the time taken, which is 10 seconds from the graph. Now if you multiply 8 meters per second times 10 seconds, what will happen to your units is you have a second above the line, you have a second below the line. They'll actually cancel out, and you'll wind up with a distance of 80 meters. Okay? Now, how did we get this? We got this by multiplying what was on the y-axis, or the speed axis, by what was on the time axis, or the x-axis. Okay? And what we say is that this is kind of like getting the area. Now, please don't get confused too much. I do know it is a little bit confusing, because area is usually measured in meters squared, not in meters. But this one works out to have a distance in meters, okay? And that's because you're really not getting an area at all. You're just taking a speed and you're multiplying it by a time. It just graphically comes out on our graph to be the area between the line graph and the time axis. Now, this is a good rule of thumb to follow with all of these graphs. You take the area between the line graph and the time axis. So this time it turned out to be a constant speed of 8 meters per second. But in other examples, it will come up at an angle. So that means we'll be still getting the area, but we might be using a triangle instead. Okay, so you guys will have to figure out, or you'll have to know the area of a triangle for the other example that we were just working with.